Hello all, welcome back to our webinar series, and this is the part 6 of the workshop that we have been conducting here. So when you talk about a embedded system, you can't stop talking about the semiconductors. So semiconductors play a major role in embedded system. So if you are not aware of the type of semiconductors that are used in the industry for the manufacturing of ICs or any other components, then you have missed a major part of the embedded system. So just to give a basic view, the major semiconductor materials that are used for the manufacturing of electronic components, whether it be ICs or whether it be active components, passive components. So the materials that are used are silicon, germanium, gallium arsenide, gallium nitride, gallium arsenide phosphide, and then cadmium sulfide. When you see, silicon and germanium are the discrete semiconductor materials, whereas gallium arsenide, gallium nitride, and etc. are compound materials. So you see a wide variety of semiconductor materials that are used. But when you go to history, or when you remember your college days, you might have seen more of a silicon and germanium in your textbooks. There isn't any other reason except that these both are most widely available. That is why we talk more about this. And among that, silicon is much cheaper, availability is more. And one of the major property of silicon is that it is less sensitive to temperature. That means the temperature variations will have lesser effect on the silicon material. So that is why even today silicon is the most widely used semiconductor material for the manufacturing of ICs. Now if you see, one more advantage of semiconductor materials, especially the silicon, is that it can easily be oxidized in the sense it can react with oxygen quickly and form a compound. So when we go further into the different types of semiconductors, we see MOSFET where SiO2 is used predominantly. So we will discuss that later. So that is one of the major advantage of silicon. And then another thing is, so now we need to know why germanium is not used. So the major thing with the germanium is that it is highly sensitive to temperature, unlike the silicon. So that is why this is less reliable. So when you say highly sensitive to temperature, we know that it can be used in photosensitive applications. That means it can react quickly with the heat, and then the properties can be changed. So that way, if you find any photosensitive applications, you see germanium more. Now today is a generation of high speed or RF. So what kind of semiconductor is used in such applications? So when you ask this question, gallium arsenide is a most preferred semiconductor material. So why gallium arsenide is used is the mobility of gallium arsenide is high. When you say mobility, there will be a charge carriers inside each and every material. So the charge carrier mobility of gallium arsenide is higher. So that is why it is preferably used for high speed applications. Now when we dig further, the basic semiconductor materials, okay, are silicon and germanium. These are basically called the intrinsic semiconductors because they are not doped. They doesn't have any free electrons. Now when they are doped, that means some impurities are added. They become p-type and n-type. Such type of semiconductors are called the intrinsic semiconductors, and in this case they form free electrons which help in the conductivity of the semiconductor. Now when these are formed as extrinsic semiconductors, you will have a p-type and n-type semiconductor. So silicon combined with arsenic forms n-type, and silicon combined with boron forms the p-type. So and then below you see the latest trends which are in semiconductors. So hope you had a basic view of semiconductors here.